And good. Okay, students, we are doing lesson 8.6, volumes of pyramids and cones. Make sure you have colors handy and a calculator. Colors and a calculator. So taking a look here, you want to be looking right here on your preview notes. Make sure you get a sign-off, date and time. And here is your review problem. I want you to take a stab at this on your own. I'm going to set the timer for 2 minutes. I want you to find the volume of this prism. And you're going to follow this step. Shade the bases, find the equation of the base, circle, plug, chug. I want you to find the volume of that prism. I'm going to set the timer for 2 minutes, and then we'll go over it. Okay. Okay, let's see how far you got. So far, these are your 5-step shade base equations, circle, plug, chug. So the very first thing is you should have shade the bases, which are these two guys, because they are congruent, parallel, and connected by rectangles. Now we write our base equation, which is area equals leg, which is going to be 12 is one leg, times the other leg, leg times leg, 16 over 2. That is our base area equation for a right triangle. I'm going to take this in, is it 6 times? 96. You should have gotten 96 kilometers squared, and that is your base. And then we come for volume. It's area of the base times the height. Remember, height is the distance between the bases. So you put 20 as your height. And your base is at 96. So it's 96 times 20, which is basically just 96 times 2. I'm going to do the math longhand. So it's 1,920 kilometers cubed because it is volume. All right, so that is how to find the volume of a prism and a cylinder. Now today we're going to shift and we are doing pyramids and cones. Pyramids and cones. Make sure you have a calculator handy. So the pyramid and cone family, prisms have 2 bases, pyramids and cones have 1 base and a vertex. Vertex for all of these. That's a vertex. The way we draw this is you just connect the corners to the vertexes. And remember, the edges that you can't see, you need to dot. So those back edges, we dot. All right. Now, what makes a cone different from a prism is that a pyramid and a cone, they only have one base. They have one base and a vertex instead of two bases. So a prism and a cylinder have two bases. Pyramid cones only have one base and joined at a single point called a vertex. David, it's to the right, buddy. Yeah, a little bit farther. Periods 7 and 4 are pretty much right in the middle. Okay, so because there's a slant, there's two different kinds of heights, and it's really important you understand this. This is called the Muttart Conservatory in Edmonton. I have family there. And let's pretend you are standing right here at the vertex. And you got some sort of specialized skis. And if you were to ski straight down the middle flank there, that is called the slant height. So it's a type of height, but it's slanted, and we use a Kritzeff L for that. So that's called the slant height. Slant height. So if you ski down the side, that's slant height. Now, if you could, let's pretend you have a rope and you drop a rope right down the middle, right to the middle, inside, that's called true height. Normally it's dotted because you can't see it, and that smacks the exact middle of the base at a right angle. That's your true height, and we use the variable h for that. Did you find one? So slant height goes down the slant. True height is inside, drop down the middle. Don't mix those two up. Now, in a pyramid and cone, there's two types of height. So this is an actual paper cone here. There's the slant height, which is down the side. And we use a Kritzeff L there. What quotes around it. So we have slant height. And then if you were to go right down the middle of the cone, straight down at a right angle to the base, that's the true height. We use a H. That's called the inside height. It's also called the altitude. And we use an H for that, for true height. Always. And H always means there's a right angle. Always, always, always. Now, in this case, let's trace our, let's go up the slant height. Ready? Go up the slant height, down the altitude, and across to the radius there. See what we just did? What kind of triangle, sir? There goes that right triangle again. Okay, so in cones, the slant height, the true height, and the radius makes a right triangle. Now we're going to talk about volume here. When we deal with volume, volume is an inside measurement. So we use the inside slant height, the inside true height. Volume is the guts on the inside. So volume, too fast. Volume, just put a little V here and draw a little arrow here, like here. Volume is inside. Do you catch that? Volume is inside. It's like the water inside the cup. And because it's an inside measurement, we use the inside true height or altitude. And that's where H comes in. Volume is an inside measurement, so we use the inside true height, also known as the altitude. Okay. Volume is 3 dimensions. So if you go from a prism, just draw the 2 outer edges of the prism there. You should feel that. When you go from a prism to a pyramid, you should be able to feel you're losing volume. When you go from a rectangle to a triangle, you lose volume. Does that make sense? You lose volume. Therefore, the fraction from this to this, since volume is 3 dimensions, we lose a third. If all other dimensions were the same, the pyramid would be 1/3 the prism. So we know the volume of this. If you were to get the whole inside, the volume of the prism is just base, area of the base times the height. Volume of your pyramids and cones is base times height divided by 3, or times by 1/3. Okay, turn the page. We'll do some problems together. Okay, so we just learned volume of a prism is going to be the area of the base. I'm going to do that in green. Notice I just shaded that. That means area of times your height, which is the distance between the bases. And there's only one height in a prism. Volume of a pyramid, again, you start with area of the base. There's only one. Notice I'm using a capital B. Times the true height, which is the height straight up the middle inside. But then it's divided by 3. And how do I remember this? Because volume is 3D, therefore we divide by 3. Because we're losing volume. When we come to a point, we lose volume. Okay, the volume is 3D, therefore the fraction from a prism to a pyramid is 1/3. Because we're losing volume when we go to a point. Does that make sense? Yeah. Put your arms up like this, say prism. Now go to a pyramid. Do you feel you're losing volume? Okay, we're losing in a 3rd dimension, 3 dimensions, so we're timesing by 1/3. 3D divide by 3. Good? Make sense? Yeah. Okay. So ready? Let's do one of these together. Okay, step 1, just like the prisms, you always start by shading the base. Now there's only 1 instead of 2, so we shade the base. That's why we shade it. What shape is your base there, sir? What shape is it? It's a square. So we go like this. We shade it. We write our equation, which is side squared. So this is going to be 6 squared. 36, and we check units, centimeters squared. Now box that and write big fat the word base. Make sure you use a capital letter. Okay, ready? Now comes the fun part. Trace the slant height. What's our slant height?
5 centimeters.
So that's 5. Okay. Drop down the true height. Do we have that?
No.
I'll call it X. Okay, ready?
That was H.
Or technically it should be H, but I don't want you to get it confused with hypo. So yes, it's the true height, which will be H. Good call. Okay, now trace from here to here. Physically trace that. Now watch, we're going from the center to the edge. The whole thing's 6, so what's this squiggle? Bingo. Let's pull this out so we can see it. That's 3. That is 5. That is our X. You guys see what you're doing here? You got 2 legs, so it's going to be leg squared plus, leg squared equals hypo squared. Students, I want you to figure that out on your own. I'll come back in 30 seconds.
X equals 4.
Theta over 360. Okay, times pi r squared. So it's just 9 times 9 is 100 over 360 and pi. And you just half away up. Okay, so you should have x squared plus 9 equals 5. That's x squared. X squared. Okay. It's perfect now. And what'd you get, ma'am? The height. 4. Okay, now we write out our equation. Volume equals capital B for base times the true height over 3. Now we circle plug check. We have our base. Our base is not 6, it is 36. That's right. So we're going to go 36 times our true height that we just found, which is 4, over 3. Key to multiplying is not actually multiplying here. That is so right. So I'm going to go 3 goes into 36 12 times. 12 times 4. That's going to be 48. 4 times 12 centimeters cubed. Box that, write the word volume. It was 36 divided by 3, sir. Divided and you times. Okay. Let's try another one. In fact, I think it's just one more. Yep, it's one more. And what we're going to do, we're going to do this in pi form, and then we'll change it, and it's shade-based equations. Circle plug check. Shade-based equations. Circle plug check. Say, shade-based equations. Circle plug check. Let's see where we're at. This is a short one. Ready? Step 1, let's shade the base. What shape is that? It's a circle. So we write the circle equation, which is pi r squared. Okay, now take a look. Physically trace your radius. We do. Look very carefully. So the whole diameter, there's that bracket right there. That whole diameter is 18. That makes our radius 9. So we're going to put in pi 9 squared. So our base, use a capital B, is going to be 81 pi centimeters squared. That's your base area. Let's trace our true height. Do we have our true height? Right down the middle?
Yes.
Right angle? We have our true height. So that's our H is 12. Now we write out our equation. Volume equals area of the base times the true height. Divide by 3 because it's a cone. And we circle plug check. Circle, circle. Circle height, pick it up. I'm going to give you guys a few seconds. Hack away that on your own. Check you guys.
324.
Answer with that.
More time. This way, man, is it? Processing and
Yeah.
right. This way. Thank you.
All righty, so let's see how you finish this off. If you're smart, you can do it without a calculator because that is a 4 right there. We're going to do 81 times 4. So that you see your total volume is 324 pi form. Don't drop your pi. Centimeters cubed. And you are done. Really important that you take the time and attempt to memorize these two equations. Make sure you know the difference between a prism and a pyramid volume.